Manually creating highly configurable dynamic modules that expose async methods, be it register async, for root async, is quite complicated, especially for newcomers. You may have seen methods like these when working with official Nest packages such as typeorm or GraphQL. In these packages, you've certainly done things like typeorm module.forRoot or forRoot async when working with them. If you have ever tried to create your own dynamic module that accomplishes similar things, you may have realized it's not very straightforward and involves quite a bit of boilerplate. This is why Nest exposes a somewhat new class called the Configurable Module Builder, which helps us facilitate and simplify this entire process and lets us construct a module blueprint all in just a few lines of code. While creating basic configurable modules is a pretty straightforward process, leveraging all the built-in features of the Configurable Module Builder might not be that obvious. In this lesson, we'll showcase all the features that the Configurable Module Builder provides and how it makes things significantly easier compared to doing everything manually. So for demonstration purposes, let's start things off by generating a new module with the Nest.js CLI and call it HTTP Client Module. Next, alongside the newly generated module file, let's create a new HTTP Client Module definition file. Inside this file, let's construct a new configurable module class using the Configurable Module Builder exported from the Nest.js common package. As we can see, to create a new class, we simply have to instantiate a new builder instance and call the build method on it. Next, let's make sure we also specify an options interface for this module. Here, we've specified that our module takes an object consisting of one optional parameter, which is the base URL that we will use for our HTTP client as an options object. With all of this in place, let's switch to our HTTP client module and make sure our class extends the configurable module class as follows. Now, if we navigate to the app module and type dot after we try to import our HTTP client module, our IDE will show us two new predefined methods, register and register async. If we type register and go inside the parentheses, we'll see that it even shows us our options object. Alternatively, we could also use the asynchronous variant and we will still have all the IntelliSense in place for our options object. Let's stop here for a moment. While building applications with Nest.js, you may have seen methods like forRoot, register, and forFeature around some of the Nest.js packages, and you might have been wondering what the difference are for all these methods. Well, there is no hard rule about this, but all the Nest.js packages try to follow a few simple guidelines. When creating a module with register, we are expecting the module to be able to configure a dynamic module with a specific configuration for use only by the calling module. You can do this for as many modules as you want. With forRoot, we are expecting to be able to configure a dynamic module once and reuse that configuration in multiple places, though possibly unknowingly as it's abstracted away. This is why you have only one GraphQL module forRoot, one typeorm module forRoot, etc. With forFeature, we are expecting to use the configuration of a dynamic module's forRoot, but need to modify some configuration specific to the calling module's needs. Let's say, for example, which repository this module should have access to, or the context that a logger should use. All of these methods usually have async counterparts as well. Register async, forRoot async, and forFeature async. They typically achieve the same thing as their counterpart, but they use Nest dependency injection for the configuration in order to handle things asynchronously. Back to our task at hand, to test everything out, let's navigate to the module definition file again and export the module options token from the result of our new configuration module builder. As a best practice, we also recommend renaming that constant to avoid misimporting the wrong module options token. This may come in handy if you have multiple modules using the configuration module builder class. In our case, we're going to rename it to be HTTP module options. And with this in place, let's open up our HTTP client module and inject the options object there using the standard approach. Let's also console log the options object just so that it shows up in our console to see what it actually is. Let's make sure to save our changes, open up our terminals, and see what got logged to our console. And as we can see, we have the base URL and nestjs.com that we passed in. So far, so good. Let's switch back to our module definition file and see what other possibilities we have. The configurable module class by default provides the methods register and its counterpart register async. To use a different method name, we can use the setClassMethodName method as follows. Now if we navigate to the app module file, we'll see that register is no longer present. Instead, we have the forRoot method. Back to our module definition, let's comment out that line as we want to keep using register. Another useful method we might want to use is setFactoryMethodName. Since the register async method, or forRoot async, or any other name you have chosen depending on your configuration, lets consumers pass a provider definition that resolves to the module configuration, a library consumer could potentially supply a class to be used to construct the configuration object. This class, by default, must provide the create method that returns a module configuration object. However, if our library is supposed to follow a different naming convention, we can change that behavior and instruct Configurable Module Builder to expect a different method, for example, resolve as we're showing here. Now, if someone used the async configuration variant and decided to provide a configuration factory class, this class would have to provide the resolve method here. Again, let's comment this out, as in our example, we can just use the default value. We just wanted to showcase the possibilities here. Moving on to another interesting use case for the configuration builder is when our module needs to take extra options that determine how it is supposed to behave. Imagine an option such as the isGlobal flag, or just global, which at the same time, an extra option like this should not be included in the module options token provider, as those options are irrelevant to services and providers registered within that module. Take for example, HTTP client, which itself does not need to know whether its host module is registered as a global module or not. But these options are important to those using our module, so ideally we would want to include them as additional options. To achieve all of this, we can use the setExtras method. The first argument passed into the setExtras method is an object containing default values for the extra properties. The second argument is a function that takes an auto-generated module definition with providers, exports, etc., and the extras object which represents extra properties, either specified by the consumer or defaults. The return value of this function is a modified module definition. In this specific example, we're taking the extras.isGlobal property and assigning it to the global property of the module definition, which in our case determines whether a module is global or not. Now, if we save our changes, navigate back to the app module file, we'll see that we can pass in this additional isGlobal flag now if we wanted. And even though we passed in this property here, if we look at our console, we'll notice that it does not show up there. This is because, as we've mentioned above, extras can be used to modify the auto-generated module definition, but they are not registered as part of the options object or provider. One thing that we did not touch on yet is that currently this property isGlobal we added is always required. So how can we make sure it is optional instead? Back to our modules definition file, let's specify the type argument of the setExtras method as follows. And voila, the isGlobal property is now optional. Now, for demonstration purposes, let's open up the app module file again, remove the isGlobal prop we just added, copy the HTTP client module import, and paste it multiple times. Let's save our changes, open up our terminals, and take a look at the logs. As we can see, even though we imported HTTP client module multiple times, only one module was actually created. But why is that? Well, in Nest, every module is represented as a node in a directed graph, meaning that nodes have specified directions. Every node has its unique hash that's generated based on the module's definition. If there's an existing node with a specific hash, then Nest points to that node instead of creating a new one. This all means that when we have 3 HTTP client module imports and each module shares the same configuration, only one node will be created. However, when we change base URLs to be unique as follows and save our changes, we'll see that now we have 3 modules created instead of 1. Let's revert this change and use the same URL for all of our imports for now. Let's save those reverted changes and switch back to the module definition file. Let's pass the configuration object to the Configurable Module Builder constructor, setting the always transient property to be true to see some different functionality. Let's save our changes, open up our terminals, and as we can see, there are 3 HTTP client modules now, even though they all have the same configuration, because the module is transient now instead. This could be useful in situations where you want to ensure that every creation of the module is in fact unique. Back to our Configuration Module Builder options object, there are 2 other interesting and useful properties you might want to use. Options injection token, which lets us specify under which token the options object should be registered. Note that this is auto-generated by default. And module name, which lets us specify the module's name, which can be useful for simpler debugging, etc. Also note that the build method returns an object, and so far we've only used two properties of that object: configurable module class and module options token. There are two other properties that may come in handy if we wanted to override the auto-generated register and register async methods, which are options type and async options type. Now, let's switch to our HTTP client module and see how we can use them. As we can see, now we can make these options types available for use, since sometimes we may have different configurable options between register and async register methods. So in this lesson, we've covered a lot and done a deep dive into all the functionality available with the configuration module builder. Hopefully you can see the power and time-saving capability that this builder provides in creating dynamic nest modules with as little boilerplate as possible, all while still having complete control over the dynamic module process for your end users.